What if the universe wasn't silent that night, but listening? In late September, a massive coronal mass ejection erupted from the Sun, its plasma wave curving away from Earth and striking something not of this solar system. The interstellar object known as 3I Atlas vanished from telescopes within minutes, its luminous tail extinguished as if swallowed by the void. Then, across Earth, magnetometers spiked, satellites glitched, and a strange rhythm pulsed through our planet's field, a frequency no one could explain. The official reports called it coincidence. But the timing was too perfect, the geometry too exact, and the silence from deep space monitors too deliberate. Tonight, we follow the trail of data, the gaps in transmission, and the whispers buried in solar noise, to uncover whether the sun's storm awakened something in the dark. Stay until the end, because this story doesn't end where science says it should.
The CME that changed course. It began with a forecast, routine, unremarkable, easily overlooked among the daily storm alerts from the sun. A coronal mass ejection, modest by solar standards, was predicted to graze Earth's magnetic field sometime in late September. The alerts were issued, satellites were placed on standby, and most scientists expected the same thing that happens hundreds of times a year: a mild geomagnetic flicker, a colorful aurora, nothing more. But that's not what happened. The first signs of anomaly came from the Solar Dynamics Observatory, which detected a subtle twist in the plasma's ejection pattern. Instead of expanding symmetrically outward, the CME began to curl, as though tugged by an unseen force. Its projected path bent away from the ecliptic plane, missing Earth entirely. To the public, that meant safety. To heliophysicists, it meant confusion. The sun's behavior is chaotic but predictable in broad strokes. CMEs don't just turn mid-flight, not without help. At first, analysts blamed the magnetic complexity of the eruption site, active region 3T832, a volatile patch that had been producing M-class flares all week. But that explanation fell apart when secondary CMEs from the same region traveled normally. Only this one, the so-called delta event, showed an unmodeled trajectory drift. The deviation was subtle but undeniable. By the time it reached interplanetary space, it was no longer heading for Earth. It was aiming toward a faint,
icy traveler, 3I Atlas. At that point,
3I Atlas was already the subject of quiet fascination. An interstellar object, the second ever confirmed after Oumuamua, it was passing through the inner solar system on a hyperbolic path,
untethered to our sun. Its speed, composition,
and greenish hue puzzled astronomers. But when orbital simulations revealed that the redirected CME would intersect the comet's path almost exactly, the coincidence became impossible to ignore. Behind the scenes, agencies took notice. The ESA's Solar and Heliospheric Observatory, SOHO, flagged the anomaly in its early models. NASA's Helioanalytics division issued a brief, encrypted bulletin noting a path divergence inconsistent with solar wind models. It wasn't a warning, it was an admission that something didn't fit. Then silence. The trajectory data were reclassified under internal review, and the event slipped from the public feed. Yet, fragments of data still leaked. Independent researchers using the SolarSoft analysis suite noticed that the plasma density map along the CME's axis fluctuated strangely, as though a portion of the mass was accelerating faster than the rest. A CME is a magnetized plasma bubble. It doesn't accelerate mid-space, unless something was pushing or pulling it. That's where the first speculative theories began. Some proposed that 3I Atlas itself possessed a magnetic field strong enough to alter plasma flow. But interstellar objects that size, barely a few kilometers across, shouldn't generate measurable magnetism. Others suggested that the CME had encountered a dense pocket of interplanetary dust, redirecting its course. But the interplanetary medium is thin, too thin for such a dramatic deflection. A more unsettling possibility emerged, that the CME was responding to a magnetic topology extending from the comet, something external, maybe an induced field or plasma sheath invisible to traditional sensors. In other words, 3i Atlas wasn't a passive target. It was interacting. By the time the solar plasma reached the region near the comet, multiple spacecraft detected subtle anomalies. Stereo A recorded brief distortions in heliospheric current sheets, fine ripples traveling opposite the CME's direction. Parker Solar Probe noted an increase in charged particle density, even though it was millions of kilometers away. The patterns were too synchronized to be random noise. When the CME finally collided with the vicinity of 3i Atlas, Earth-based telescopes expected a brightening event, the ionization of gas and dust, the creation of a stunning new tail. Instead, the opposite occurred. The comet's tail dimmed. Within hours, it was nearly gone, as if the plasma impact had extinguished its glow rather than inflaming it. That paradox forced investigators to revisit the event from the beginning. What if the CME's deviation wasn't accidental?
What if it had been guided, drawn toward the object by an interaction we don't yet understand?
In heliophysics, CMEs travel along magnetic field lines, massive invisible arcs that shape space around the Sun. But these lines aren't supposed to connect to interstellar intruders.
Unless the intruder is carrying a charge, or worse, reflecting one.
A team at Kyoto University ran magneto-hydrodynamic simulations of the event, inputting the data from ESA's public records. Their model suggested that a magnetic anchor point could have formed between the CME's flux rope and an ionized coma if the object's surface conductivity was unusually high. The numbers fit, but only barely. For the CME to turn that sharply, the comet's interaction region would need to behave like a giant magnetized mirror. In normal physics, impossible. But in plasma physics, under extreme charge separation, maybe not. Then came another wrinkle. Amateur astronomers in Chile and South Africa captured a faint secondary arc of light trailing behind the main CME. It wasn't a natural continuation, it curved back toward the Sun. That curvature implied magnetic reconnection, an energy feedback loop. Something about the impact caused the plasma to fold upon itself, momentarily linking the Sun and comet in an electrical circuit spanning millions of kilometers. If true, that would be unprecedented. It would mean energy transferred both ways. The Sun touched an interstellar object, and something answered back. Afterward, the official data pipeline grew quiet. Solar observation feeds lagged, certain images were withheld, pending calibration, and the daily space weather reports omitted the anomaly altogether. But deep in the archives, time-stamped telemetry remained. Independent analyst groups, among them a loose network of ex-mission scientists and citizen physicists, cross-referenced proton flux graphs from multiple spacecraft. They discovered a narrow pulse exactly at the timestamp of the collision. It lasted just 2 minutes, too short for any typical solar feedback. But it was real, verifiable, and perfectly aligned across multiple sensors. Those who study cosmic synchronicity see patterns like this as messages, feedback loops between star and space, between magnetic storms and visiting bodies.
Of course, official science doesn't speak that language.
It prefers terms like magnetic reconnection, flux realignment, or anomalous propagation. But even those terms can't erase the unease. A CME changed course and made contact with something from beyond our solar system. The implications ripple outward. Could interstellar objects like 3i Atlas serve as conductive nodes, temporary relays that bridge stellar systems magnetically? If so, every solar system they pass through could leave an imprint on their surface, a record of energy exchanges older than our Sun. The idea sounds poetic, but data keeps nudging in that direction. Since that September event, models of solar wind density have shown lingering distortions along the CME's original path, ghost currents that fade slower than physics predict. It's as if the magnetic topology itself remembers the interaction. No one will officially call it a solar scar, but in the research community, that's the whispered term. Some researchers went further, correlating the event with Earth's magnetic environment. In the hours after the CME's deflection, magnetometer readings across the northern hemisphere twitched, not enough to trigger alarms, but enough to notice. These blips formed a repeating harmonic pattern, matching the CME's oscillation frequency. Coincidence, perhaps. But if the Sun and the comet momentarily linked, it's possible Earth's field resonated in response, like a tuning fork picking up a distant tone. The skeptic's view is simpler. Data artifacts,
Measurement noise, pattern-seeking minds.
Yet those same skeptics have no better explanation for the CME's deviation. The forces required are calculable, but no known object, interstellar or otherwise, should have been able to exert them. When all the math is stripped away, what remains is a single, chilling observation. Something bent the Sun's will, and in cosmic terms, that's not supposed to happen. For centuries, humanity has treated the Sun as the unshakable center, the force that moves everything else. But this time, a wandering fragment from beyond our neighborhood may have turned its fury aside. Whether that act was accidental electromagnetic or something stranger, no one can yet say. But as scientists comb through silent datasets, amateur astronomers replay their recordings, and magnetic models flicker with unexplained signatures, one idea persists like an echo through plasma. What if 3i Atlas wasn't merely passing through our system? What if it answered the Sun? And if that's true, then perhaps this CME didn't just change course in space, it changed the course of what we believe about the forces that shape the universe. The vanishing tail phenomenon. When the coronal mass ejection finally met 3i Atlas, astronomers expected a spectacle, a brilliant surge of ionized gases stretching for millions of kilometers, glowing vividly as solar plasma struck volatile ice. Instead, something impossible happened. The tail disappeared, not dimmed, not shortened. It was gone. At 0311 UTC, telescopes from Chile to Hawaii recorded the interstellar object's signature green halo flickering, then collapsing into near invisibility. By 0317, only the faintest nucleus remained, a ghostly speck against the stars. The loss was too sudden, too synchronized across instruments to be blamed on viewing angles or equipment failure. For a moment, it seemed as though the object had simply been erased. The first reports came from the Mauna Kea Observatory. Their data logs showed a 93% drop in visible luminosity within 6 minutes. Analysts assumed a software glitch until cross-referencing data from the European Southern Observatory confirmed identical readings. NASA's solar orbiter, stationed millions of miles away, detected a simultaneous drop in reflected sunlight from the object's trajectory. The universe had blinked, and something had changed. But what? Traditionally, when a comet interacts with solar plasma, its tail brightens as charged particles excite gas molecules, a cosmic neon sign. The more intense the solar wind, the brighter the display. Yet 3i Atlas defied this fundamental principle. The solar storm that struck it was fierce enough to supercharge the tail tenfold, but instead of radiating light, the comet went dark within hours. Social media accounts of amateur astronomers lit up with speculation. One posted, "It's like it got swallowed by its own shadow." Another claimed to see a secondary flash, a brief green pulse, seconds before the disappearance. That pulse would later become central to one of the strangest debates in recent space history. NASA remained quiet. Their official statement, issued 48 hours later, dismissed the event as a temporary optical phenomenon caused by over-ionization. But behind closed doors, internal memos told a different story. Leaked correspondence from the Deep Space Network described complete reflective failure and unexpected signal absorption. In other words, light, plasma, and telemetry simply vanished into the object. The most obvious question followed: could the CME have stripped the tail away entirely? If so, that would mean the solar wind exerted enough pressure to blow off the comet's gaseous envelope. But even the strongest CMEs lose coherence over distance. and 3I Atlas was millions of kilometers away from the Sun when the event occurred. The energy shouldn't have been sufficient. Not even close. Astrophysicists proposed several competing theories. The first was magnetic neutralization. That is the idea that charged solar plasma might have balanced or short-circuited the comet's own ion stream, collapsing its luminous structure. In this model, 3I Atlas's tail didn't vanish. It simply lost the electric potential required to glow. But magnetic neutralization should happen gradually, not in a clean, seconds-long collapse. The second theory was sublimation inversion. If the CME's radiation triggered sudden outgassing from deeper layers, dense dust could have temporarily obscured the glowing tail. But dust clouds scatter sunlight, they don't absorb it entirely. And yet, observational spectra during those critical minutes showed no reflection.
No scattering or nothing. Then came a third,
more unsettling hypothesis: energy absorption. According to this model, the tail didn't fade because it was destroyed. It faded because the material became transparent. Under certain high-energy conditions, plasma can shift into a metastable state where it absorbs light rather than emitting it. Some called it a dark plasma phase, a theoretical transition never observed in nature. If this occurred, 3I Atlas might have become temporarily invisible, not gone, but cloaked by its own altered state. When astronomers at the University of Bern examined the spectrographic data, they found something chilling. The emission lines for carbon, oxygen, and cyanogen, the usual fingerprints of cometary gas, had not vanished completely. They'd moved, shifted toward shorter wavelengths in a pattern inconsistent with Doppler effects, as if the chemical bonds themselves had changed. We weren't just watching the tail disappear, one researcher noted. We were watching its chemistry evolve in real time. Meanwhile, another oddity emerged. During the period of disappearance, multiple ground-based magnetometers detected a faint pulse, not strong enough to trigger a geomagnetic storm, but measurable. The pulse had the same periodic frequency as the CME wavefront. It was as if the energy that should have illuminated the comet had echoed across interplanetary space. Coincidence?
maybe, but the timing was perfect. Then, 13 hours later, something even stranger occurred.
The comet's faint core brightened again, but not in the same color. The green hue characteristic of carbon-based gases was replaced by a pale, bluish-white glow. Its spectral profile resembled ionized nitrogen, a compound not previously detected in 3I Atlas. Somehow, its chemistry had rewritten itself. Was the CME's energy sufficient to transmute its materials? The math says no, but the data refuses to agree. In an unpublicized session, scientists at ESA ran simulations using the heliospheric magnetic imager. Their results showed that the CME's embedded magnetic field could have induced electric currents within the comet, generating localized plasma discharges. Those discharges might have restructured the molecular composition of its surface, effectively reprogramming the object at an atomic level. But the question remained, why did the tail vanish rather than explode? Here, independent researchers noticed something the agencies overlook. The final images before disappearance showed faint concentric ripples expanding outward from the comet's coma, similar to interference waves. Those ripples behaved as if the comet's electromagnetic environment had collapsed inward, like a magnet reversing polarity. What if 3I Atlas temporarily became magnetically repulsive, weren't attracting charged particles from the solar wind, but pushing them away? In that scenario, the tail wouldn't burn or scatter. It would retract, pull backward along its own field lines, until nothing remained.
Visible, the idea sounded absurd until it
Wasn't. A paper quietly uploaded to Ejection by two plasma physicists proposed that interstellar objects, unlike native comets, might carry exotic charge ratios accumulated over eons of interstellar travel. When exposed to a solar magnetic storm, these charges could invert explosively, leading to short-lived electromagnetic collapses. If that happened, the object would behave like a mirror turned inside out, momentarily reflecting nothing. For observers on Earth, that would look exactly like what happened, a vanishing. But hidden inside that darkness, something else might have occurred. Radio astronomers at Jodrell Bank Observatory detected a faint, narrowband emission near 1420 Mhz, the hydrogen line, during the same window. It lasted only seconds. The source direction matched 3I Atlas's coordinates within margin of error. The signal was dismissed as interference, but some noticed it bore structured harmonics, not random noise. To this day, no one has explained it. After the event, as the comet's faint new glow returned, its trajectory measurements showed another irregularity. The velocity vector had shifted by a fraction of a degree. Small, but real. The energy required for that adjustment exceeded what the CME could have imparted through momentum transfer. Something else applied force. Was it internal? Did the CME trigger outgassing jets invisible in the altered light spectrum? Or was it external? The echo of magnetic pressure from an unknown field interaction. Weeks later, NASA's official trajectory update omitted the anomaly. Independent orbital modelers reinserted it and found that if extended backward in time, the shift aligned perfectly with the CME's impact moment. The conclusion was unavoidable. Something inside the event imparted thrust. This is where speculation veers toward the metaphysical. Some theorists suggest that interstellar objects like 3I Atlas might possess compositions unknown to our periodic table, materials that react unpredictably to solar radiation, storing and releasing energy in ways our sensors can't detect. Others take a darker route, that 3I Atlas wasn't a natural object at all, but a relic, something engineered, now awakened by the sun's touch. Of course, those claims remain beyond proof, but what cannot be dismissed is the chain of measurable facts. A coronal mass ejection met an interstellar object. Its tail disappeared, its chemistry shifted, and its path subtly changed. Each of those by itself might be explained away. Together they form a pattern, one too precise to ignore. Somewhere in those missing minutes of light, something happened between the sun and the stranger passing through our system. Energy moved, matter transformed, and visibility itself was undone. The universe did not simply show us less. It took something from sight entirely, and if plasma can turn dark, if matter can hide from the light that made it, then what else might the cosmos conceal behind its storms? The magnetometer spikes it began as background noise, harmless static in a sea of solar data. Magnetometers around the world record fluctuations in Earth's magnetic field every second of every day. Most of it is meaningless, harmless shifts caused by the solar wind brushing past our planet, by auroras, by power grids, even by lightning. But on the night 3I Atlas's tail vanished, that noise changed across 3 continents. Instruments that had nothing to do with one another, run by universities, space agencies and private research groups, registered a pulse. It was faint, just a blip on the graphs, but it appeared everywhere at the same time. The timestamp, 03:14 UTC, the very moment the interstellar object went dark. In Alaska, the HARP array picked up a sudden spike in ionospheric current. In Norway's Lofoten Islands, magnetometers twitched with an identical signature, an upward surge, then a sharp trough, as if something had tugged on Earth's magnetic field before letting go. And in Chile, at the Cerro Tololo Inter-American Observatory, a portable fluxgate magnetometer showed the same pattern. 3 locations, 3 hemispheres, 1 global pulse. The first instinct was to blame instrumentation error. But these stations weren't linked by software or hardware. Their readings were independent. More troublingly, they were all precisely in sync, down to the millisecond. That alone was impossible. NASA's Space Weather Prediction Center took note, but said nothing publicly. The official report filed days later called it a localized calibration.
Anomaly. Yet no one could explain why the anomaly repeated in data.
Archives all around the world. When independent analysts began comparing notes, they noticed something stranger. The waveform of the spike wasn't random. It matched the harmonic frequency of the CME that had struck 3I Atlas solar. Flares often send ripples through space, charged particles, and magnetic waves that can distort satellite sensors, but this one wasn't directed at Earth. It had missed us entirely. For our magnetosphere to respond, something had to connect us indirectly. The implication was unsettling, an electromagnetic echo traveling through the heliosphere, bouncing from the collision point of the CME and 3I Atlas, then somehow coupling with Earth's field lines. A magnetic whisper from an event millions of kilometers away. But even that didn't fully explain the readings. Magnetic echoes weaken exponentially with distance. The signal strength recorded across the three observatories suggested either an impossibly coherent wavefront or amplification. In plasma physics, coherence requires structure, a medium or conduit through which energy can stay aligned. If such a conduit existed, it would mean the Sun, Earth, and the interstellar object were momentarily part of the same electromagnetic circuit. To test that idea, a small group of heliophysicists recreated the event in simulation. Using the parameters of the late September CME and the coordinates of 3I Atlas, they mapped the propagation of magnetic flux lines through the inner solar system. The results were breathtaking. For approximately 13 minutes after impact, field lines from the Sun through the comet and out toward Earth formed a continuous chain of alignment, a perfect resonant arc. In that short window, any fluctuation at the impact site could, theoretically, echo across the system. Still, skeptics call it pseudoscience. Correlation doesn't prove connection. Maybe the spike was just an unrelated geomagnetic twitch. But then the coincidences started stacking. During the same window, a small geomagnetic oscillation was detected by the swarm satellites in low Earth orbit. They measured a subtle, rhythmic vibration in the planet's field, so gentle it couldn't be felt on the ground, yet distinct in frequency. The pattern repeated every 11.2 seconds. That rhythm matched the oscillation of the CME's magnetic flux rope as recorded by stereo A. Coincidence? Perhaps once. But when two independent sensors separated by millions of kilometers show identical rhythms, the question stops being why and becomes how. Some theorists proposed that Earth's magnetic field had briefly resonated with the interplanetary disturbance, much like a tuning fork vibrating in sympathy with another. If true, it would mean the magnetic event at 3I Atlas carried not just energy, but information, encoded in the oscillation itself. In simpler terms, Earth heard the impact, but the story doesn't end there. Within hours of the global pulse, several deep-sea sensors used for earthquake monitoring off Japan's coast recorded subtle piezomagnetic fluctuations, tiny magnetic changes within the Earth's crust. These anomalies mirrored the timing of the magnetometer spike, hinting that the energy ripple might have penetrated deeper than the ionosphere. If a magnetic resonance could reach that far, it suggested an interaction between solar space weather and terrestrial geology far stronger than standard models allow. Some began calling it the solar resonance hypothesis, the idea that planetary systems are not merely bathed in solar influence, but electrically coupled to it, capable of sympathetic reaction. NASA avoided the term altogether. In internal correspondence obtained months later, mission analysts used more cautious language, non-local magnetic coherence observed during CME deflection event. Behind those words, however, was a sense of unease because the next anomaly wasn't magnetic, it was biological. In Finland, a team studying atmospheric electricity noticed abrupt changes in Schumann resonance amplitudes, the global electromagnetic hum that oscillates between Earth's surface and the ionosphere. These changes coincided with the magnetometer spikes. For decades, scientists have speculated that Schumann resonance fluctuations might subtly affect human and animal physiology, heart rate variability, sleep patterns, even mood. If that connection exists, it means whatever reached our planet from that solar event didn't stop at our instruments. It brushed against life itself. Still, mainstream journals ignored it. Too fringe, too speculative. Yet among independent researchers, a pattern was emerging. Each anomaly, magnetic, seismic, atmospheric, fit within a narrow temporal corridor linked to a single, extraordinary event, a coronal mass ejection that shouldn't have been able to touch us at all. And then came the next revelation. A radio observatory in California, scanning for cosmic background noise, found that the spike wasn't limited to Earth. The same Aero 314 UTC timestamp appeared as a microburst in their data, an interplanetary radio flash lasting less than 2 seconds. The signal's origin was triangulated somewhere near the Sun-3I Atlas interaction region, a burst of electromagnetic radiation, synchronized with both the magnetometer spikes and the comet's tail disappearance. When overlaid on heliospheric models, the event formed a triangular geometry linking the Sun, Earth, and 3I Atlas, an energetic conduit that briefly bound all three. For those who believe in cosmic resonance, this was proof of a deeper order, a moment where celestial mechanics and magnetism intertwined, revealing a hidden symmetry in the chaos. Skeptics countered with technical arguments, instrument interference, coincidental alignment, statistical noise. But what they couldn't explain was the precision of the timing, nor the global synchronization. The odds of random error reproducing identical spikes across multiple unconnected observatories were infinitesimal. So the question remained, what exactly caused Earth's field to twitch at the same moment an alien object was struck by the Sun's plasma? Some whispered about plasma bridges, temporary filaments connecting distant bodies through charged particle flows. Plasma physicists have long observed Birkeland currents linking planetary magnetospheres to the Sun. Could 3I Atlas entering that current have momentarily extended it beyond the solar boundary? If so, Earth's magnetic spike might have been the far end of that current snapping into equilibrium, a cosmic lightning strike felt across millions of kilometers. Others proposed a subtler explanation. Perhaps 3I Atlas's unusual chemistry, once ionized by the CME, emitted its own electromagnetic pulse, a feedback wave traveling along the solar magnetic lines back toward the source. The Sun responded, the field lines resonated, and Earth, as part of that system, received the echo. Astonishingly, when researchers modeled this feedback mechanism, the predicted delay between the comet impact and Earth's signal matched exactly, 11 minutes, 47 seconds. The observed time difference was 11 minutes, 46. That precision doesn't happen by chance. In the aftermath, the data was quietly archived, the conversation closed. Publicly, the magnetometer spikes were labeled inconclusive, but among the few scientists still watching, unease lingered. Because once you accept that magnetic resonance can travel through interplanetary space, you have to ask, what else can? If a faint pulse can leap across the void, could information encoded in magnetic structure do the same? Could the Sun be sending and receiving signals through these transient circuits? That question was whispered in private labs and encrypted forums for months. A few dared to suggest it aloud, that what we witnessed wasn't a random echo, but a form of communication between stellar and interstellar bodies. After all, magnetism is the universe's oldest language, and on that September night, as instruments twitched and the planet's field sang in silent resonance,
maybe, just maybe, the Sun spoke and something out there answered.
The data gap in solar observation feeds at first, no one noticed. It was just a few missing frames, gaps so small they could have been dismissed as normal telemetry dropouts. But when the data from multiple solar observatories were aligned, the absences lined up with unnerving precision. Between 0312 and 0318 UTC, the exact 6-minute window when 3I Atlas's luminous tail vanished, the world's solar monitors all went dark. NASA's Solar and Heliospheric Observatory, ESA's Stereo A probe, Japan's Hinode mission, even the Joint Parker Solar Probe data relay all recorded simultaneous telemetry interruptions. Not total blackouts, but something more surgical, a brief loss of imaging feed precisely when the CME intersected 3I Atlas's projected position. To the public, these interruptions meant nothing. Spacecraft data gaps happen often. Cosmic rays, hardware resets, bandwidth throttles. But to solar physicists, the odds of every major instrument failing at the same time, across different platforms, in different orbits, were vanishingly small. When the feeds came back online, the images resumed as if nothing had happened. The CME continued expanding outward, the sun's surface writhed in magnetic turbulence, and official reports logged nominal conditions. But buried in internal transmission logs were 3 words that rarely appear in routine operations: unscheduled telemetry suspension. The reason? Sensor overload due to anomalous signal intensity. Translated, it meant the cameras saw something they couldn't process. The Solar and Heliospheric Observatory's LASCO C3 imager, designed to capture high-energy plasma fields, reported a saturation spike, brightness so intense it exceeded the CCD's dynamic range. For 3 frames, the entire detector readout was white noise. Yet curiously, the sun itself didn't appear any brighter. The overload came from a different region, near the coordinates where the CME was expected to meet 3I Atlas. What could cause a blinding signal from that part of space, powerful enough to paralyze multiple instruments but invisible to optical telescopes? The first explanations were cautious. A cosmic ray burst, perhaps, or a solar particle event strong enough to scramble sensors. But when telemetry from independent systems on Earth, including the Solar Radio Observatory in Nancy, France, showed an identical timing gap, that excuse collapsed. This wasn't random interference. It was synchronized omission. Researchers at the Royal Observatory of Belgium were among the first to quietly sound the alarm. They overlaid the timestamps of the blackout with ground-based data and realized the missing interval coincided exactly with a series of rapid magnetic perturbations, micropulses recorded in the solar wind stream. When the feeds resumed, those pulses had stopped. Something had happened inside the silence. The question was, what did the sensors see before they went blind? A fragment of the answer emerged days later, hidden in a data dump from a forgotten node of the Stereo A mission. The file contained a corrupted sequence of coronagraph images, only partially recoverable. When restored, the frames revealed something startling. In the first intact image, the CME appeared as expected, a wide, billowing plume of plasma. But in the final pre-blackout frame, the CME's edge curved sharply inward, as if folding around an invisible barrier. Then, static. When data resumed, the structure had changed. The CME's shape was lopsided, its expansion uneven, its direction subtly altered, away from Earth, toward the deeper heliosphere. That inward curvature shouldn't exist. Plasma doesn't turn corners, unless something with a powerful magnetic field was influencing it. Speculation spread quietly among researchers. Could 3I Atlas, an icy, non-magnetic body, somehow generate a field strong enough to warp solar plasma? Or was there something else in that space, something the sensors couldn't interpret? The official agencies said nothing. NASA's Solar Dynamics Observatory logs for that night were reclassified for data integrity review. ESA followed suit, citing instrument recalibration. When pressed for details, Spokespeople responded with a line that would repeat across several agencies. Nominal event, no anomalous findings, but nominal didn't explain the simultaneous cross-agency blackout, nor did it explain why the recovered stereo A-frames were quietly removed from public archives 2 days later. Independent analysts kept digging. They discovered that during the 6-minute gap, Parker Solar Probe's high-gain antenna briefly switched into safe mode, a behavior only triggered by extreme radiation bursts or electromagnetic interference. When the signal returned, the probe's onboard clock was 41 seconds out of sync with the Deep Space Network's master time. In deep space operations, that's an eternity. So what kind of signal could blind cameras, scramble instruments, and desynchronize clocks, all without registering as visible light? Radio astronomers at the University of Sydney offered one possibility: a burst of broadband plasma waves spanning frequencies too high for human monitoring and too low for optical detection. A transient electromagnetic storm, short-lived but dense enough to disrupt all digital receivers in its path. Essentially, the sun's instruments may have heard something they couldn't see, but that hypothesis raised more questions than it answered. For one, plasma bursts of that type usually radiate outward from the sun, not from the direction of a CME impact zone millions of kilometers away. Whatever emitted the interference was not the sun itself. It was something between the sun and the outer void. In the following weeks, a few rogue scientists started connecting dots others were too cautious to touch. If 3i Atlas had interacted electromagnetically with the CME, absorbing, reflecting, or amplifying plasma energy, it could have created a temporary discharge, a feedback pulse powerful enough to knock sensors offline. But for that to happen, the comet would need to behave like a capacitor, charging under the CME's impact and releasing energy in a burst.
A natural ice and dust body shouldn't be able to do that,
unless its internal composition wasn't entirely natural. When fragments of its spectrum data were re-examined from before the blackout, analysts noticed faint emission lines consistent with metallic ions, traces of nickel and chromium unusually concentrated for a comet, materials often found in manufactured alloys. It was an uncomfortable discovery, quietly buried in supplementary notes of a paper that never made headlines. Meanwhile, amateurs monitoring solar feeds noticed something uncanny. In the minutes after the blackout, the sun's corona displayed a ripple, a ring-shaped distortion expanding outward like a shock wave through space itself. It was faint, almost imperceptible, but measurable in ultraviolet light. That ripple corresponded perfectly to the CME's trajectory and the timing of the missing data. If that ring was a reaction, not a coincidence, then the sun had been hit back. Imagine the implications. An interstellar object, a fragment from beyond our system, not merely absorbing the sun's energy, but reflecting it in a form strong enough to cause temporary blindness in our instruments. That would suggest a level of electromagnetic interaction we've never recorded before. Of course, mainstream explanations tried to stay grounded. Data compression errors, temporary telemetry loss, solar energetic particle saturation. But these phrases only described what happened, not why. Some within the scientific community whispered about an internal lockdown, a coordinated effort to conceal what was seen during those 6 minutes. The argument went like this: if something appeared in the data that couldn't be explained, or worse, contradicted current models, it would be quietly omitted until it could be framed within accepted science. The fact that independent archives were scrubbed only deepened the mystery, and then one last clue surfaced, not from NASA or ESA, but from an unlikely source, a Japanese amateur astronomer who had been recording continuous solar imaging through his own coronagraph setup in Shizuoka Prefecture. His camera, shielded from radiation noise by thick atmospheric filters, captured faint frames during the global blackout. In those frames, a bright, needle-like structure appeared briefly near 3I Atlas's coordinates, a vertical filament that shimmered, then dissolved. When analyzed, its light curve showed an impossible trait, coherent oscillation, as if it were vibrating at a constant frequency. The man uploaded the footage to an obscure astronomy forum. Within hours, it was gone. The account was deleted. But mirrors of the video survived, and frame-by-frame analysis confirmed the timestamp, 03:15 UTC, dead center of the blackout. Was it a lens flare? A compression glitch, perhaps? But if the image was genuine, it might represent the first visual trace of the event that blinded every professional sensor aimed at the sun that morning. A concentrated plasma column, or something far stranger. Something that appeared and vanished in the silence. To this day, those 6 minutes remain the most heavily redacted period in modern solar observation. Every dataset has a scar, a hole where the record should be, and whether those gaps hide an error, a revelation, or a secret humanity isn't ready to face, no one outside those closed mission rooms knows. But deep in the heart of the heliosphere, a coronal storm met an interstellar stranger, and for 6 minutes the universe went quiet, as though watching. Then just as suddenly it looked away. The comet's altered spectrum, when the observation feeds came back online, 3I Atlas was not the same object it had been before the blackout. At first, the difference was subtle, a shift in hue, a dimming that no one could quite explain. But within hours, the change became undeniable. The comet's light spectrum, its unique fingerprint across the electromagnetic scale, had rewritten itself. Before the CME strike, 3I Atlas's spectral profile was ordinary for a volatile interstellar body, bright green emission lines dominated by cyanogen, CN, diatomic carbon, C2, and faint traces of oxygen and sodium. It was a cold traveler, illuminated by the sun's fire, its chemistry inert and predictable. But after the event, those familiar signatures vanished. In their place appeared strange, narrow-band emissions that didn't correspond to any known element or molecule. To the naked eye, the change translated into color. The comet's luminous green glow, once so vivid it earned the nickname the Emerald Wanderer, dimmed to a spectral blue-white. Its coma shimmered with metallic undertones, and its tail, when it re-emerged days later, had a pearlescent sheen unlike any known cometary dust. Spectroscopists from Chile's Cerro Coronal Observatory were the first to notice the anomaly. They ran a series of wavelength calibrations, expecting a misalignment. But when the data stabilized, the pattern persisted. 2 new emission lines had appeared in the ultraviolet region at 251.1 and 254.6. Nanometers, wavelengths unaccounted for in any known cometary spectra. Something in 3I Atlas was emitting light from transitions that shouldn't exist. NASA and ESA's Joint Solar Observation Team quietly issued a notice. Data under review. Potential contamination. Yet contamination couldn't explain why multiple instruments on different continents saw the same shift. Nor could it explain the near-perfect symmetry between the new emission lines, as if governed by an underlying harmonic ratio. To astrophysicists, that symmetry was deeply unsettling. In ordinary chemistry, spectral lines are messy, irregular, the chaotic fingerprints of random atomic motion. But the lines in 3I Atlas's post-CME spectrum were sharp, discrete, and, to some eyes, organized. Almost like a signal, the first theory proposed was chemical transmutation. The CME, packed with high-energy particles and magnetic turbulence, might have bombarded the comet's surface hard enough to rearrange its molecules, converting common volatiles into exotic compounds through spontaneous fusion. At first glance, the energy math supported it. The plasma density at impact could, theoretically, generate localized temperatures above 1,000,000 Kelvin, enough to disrupt atomic bonds. But such reactions would have left telltale fragmentation signatures, such as broad absorption bands from carbon monoxide or hydroxyl radicals. None appeared. Instead, 3I Atlas's spectrum grew cleaner, simpler, as if impurities had been erased. By now, the object had captured global attention. Amateur astronomers noticed its new glow resembled that of highly ionized metals, magnesium, maybe even titanium. But the proportions were wrong. When the European Space Agency ran comparative analysis using archived spectral data from the Deep Impact mission on Comet Tempel 1, they found a bizarre correlation. The same ultraviolet lines appeared faintly once in the milliseconds following the Tempel impact in 2005. That anomaly, long forgotten, had been dismissed as sensor noise, but now it was back, brighter, sharper, undeniable. Could two entirely separate events, 2 decades apart, produce the same spectral ghosts? The coincidence was too exact. Within days, theoretical papers flooded preprint archives, most withdrawn soon after. Some proposed that the CME had induced a transient plasma phase in the comet's materials, a metastable lattice, temporarily trapping energy and re-emitting it in forbidden wavelengths. Others, more radical, wondered if the energy burst had awakened a latent property in the object's composition, something that had lain dormant since before it entered our solar system. Because 3I Atlas was not like other comets. Its orbital path was hyperbolic, a one-way trajectory from deep interstellar space, never to return. That meant it carried materials untouched since the birth of other stars. And if those materials included compounds unknown to Earth's chemistry, the CME might have done more than heat them. It might have activated them. The shift was not limited to ultraviolet light. Infrared readings from the Spitzer Space Telescope, though faint, showed a sudden drop in thermal emission, as if the comet's surface had cooled abruptly even as it glowed brighter in higher frequencies. Energy was being redistributed in ways no model could reproduce. In Tokyo, plasma physicist Dr. Riko Hanada ran a simulation to test whether such redistribution could occur naturally. Her model required an impossible variable, negative emissivity. In plain terms, 3I Atlas's surface would need to absorb visible light while emitting ultraviolet, a thermodynamic inversion. "That's not a comet," she wrote privately to a colleague. "That's a plasma oscillator." Yet her equations fit the data perfectly. Meanwhile, ground-based telescopes detected something even stranger, a faint, periodic flicker within the new spectral lines, a rhythmic modulation repeating every 11.7 seconds. No natural process produces such precision. It was too slow for atomic transitions, too fast for rotational precession. The modulation remained steady for 72 hours, then stopped without warning. What could emit a signal-like pulse within an altered spectrum? Some speculated resonance, a standing wave trapped within the comet's electromagnetic field. Others whispered about intelligence, a pattern embedded in light, a code beyond our comprehension. NASA refused to comment on pattern speculation, but an internal memo later leaked from the Goddard Space Flight Center hinted that the agency's spectroscopy division had run frequency decomposition analyses on the 11.7-second signal. They found subharmonic nodes, frequencies nested inside each other, forming ratios consistent with musical intervals. In short, the comet was singing. Whether that song was natural resonance or coincidence remains unknown. But something about it resonated literally. Magnetometers on Earth recorded faint matching oscillations, their amplitudes modulating in sync with 3I Atlas's spectral pulses. For 3 nights the planet hummed in tune with an interstellar object. Then silence. When the glow finally stabilized, the comet's chemistry appeared permanently altered. Gone were the cyanogen lines. gone were the typical carbon and oxygen peaks. In their place stood a spectral forest of metals: iron, titanium, nickel, and something else entirely, a broad continuum where no known element should radiate. That continuum resembled nothing from comet science, but it did resemble plasma discharge spectra from certain classified fusion experiments. Those experiments had produced similar continuous emission bands when hydrogen plasmas interacted with metallic dust in strong magnetic fields. How could a comet, drifting in vacuum, replicate conditions from a fusion reactor? Unless, of course, the CME's magnetic pressure, combined with whatever conductive material 3I Atlas contained, had created a transient magnetoplasma reaction, a miniature fusion sheath flickering across its surface. If so, the interstellar object had momentarily become a star's mirror, absorbing solar energy and re-emitting it in altered form. In that sense, the comet wasn't destroyed by the CME. It evolved. ESA's last recorded spectral data showed one more twist. After the ultraviolet emissions faded, the comet's residual glow displayed faint infrared polarization, as if the light itself had become magnetized. Polarized emission from a non-rotating dust-poor body shouldn't exist. But it did. That final reading was quietly labeled instrumental anomaly. Yet the archived raw data tell a different story. The polarization vectors formed a spiral, twisting outward from the nucleus, mirroring the geometry of the CME's own magnetic structure. The Sun had imprinted its magnetic fingerprint onto the visitor, reshaping it in its own image. By late October, 3I Atlas drifted beyond the reach of most telescopes. Its brightness dropped below magnitude 16 and its altered spectrum faded from record. But the data remains. 8 days of impossible chemistry burned into sensors across the world. To this day, no laboratory can reproduce those spectral lines. No combination of elements, temperatures, or plasma conditions yields the same ratios. It is as if the object existed briefly in a state that defied conventional physics, a glimpse of matter caught between known and unknown, natural and artificial, physical and something more. Some call it coincidence, an extreme but explainable reaction to solar radiation. Others call it metamorphosis, a transformation catalyzed by energy we barely understand. But among a small circle of scientists who still review those spectral curves in quiet fascination, a different question persists. What if 3I Atlas wasn't merely reacting to the Sun's outburst? What if it was responding, changing its composition, not by accident, but by design? If interstellar objects can rewrite their chemistry in response to energy patterns, they may not just be relics of other systems. They could be archives, encoded repositories of physics, tuned to react when illuminated by the right kind of light. And if that's true, then in late September, the Sun didn't just strike an alien traveler. It activated one. The pattern of global resonance. By the time the last traces of 3I Atlas faded from solar observation, Earth had already begun to hum. It started quietly, minor fluctuations in magnetometer readings, faint increases in Schumann resonance amplitudes, and subtle electrical anomalies across atmospheric networks. To most, they were nothing, but to those watching, the timing was undeniable. The planet's pulse had shifted the moment the Sun's CME struck the interstellar comet. In Alaska, researchers at the Poker Flat Research Range recorded faint geomagnetic ripples echoing through the ionosphere. In Japan, VLF, very low frequency, monitoring stations detected disturbances in radio propagation identical to those caused by solar storms, except the storm had missed Earth entirely. And halfway across the world, in northern Europe, auroral activity spiked without any correlating increase in solar wind density. The data painted an impossible picture. Earth's magnetic field was responding to an event that hadn't touched it directly, the phrase that began circulating among heliophysicists, was non-local coupling. It implied a sympathetic link, some form of energetic resonance connecting the Earth, the Sun, and the point of impact between the CME and 3I Atlas. At first, it sounded absurd, but the evidence was stacking too neatly to ignore. Between September 27th and 29th, ground-based magnetometers around the world showed synchronous, low-amplitude oscillations. The pattern repeated every 11.7 seconds, the same interval that had been detected in the comet's altered spectrum. Coincidence seemed increasingly unlikely, and then came the earthquakes. They were small, barely registering on global seismographs, a 3.1 off the coast of Chile, a 2.9 in Iceland, a 3.0 in the Philippines, individually insignificant but clustered unnaturally close in time. Each tremor occurred within a 90-second window of the magnetometer pulses. It was as if the entire planet had flinched in rhythm with an unseen metronome ticking somewhere in space. When analysts overlaid these events on a map, a striking geometry emerged. The locations of the tremors formed a rough arc along the Pacific Ring of Fire, an arc that mirrored, almost perfectly, the curvature of the CME's trajectory as it swept past Earth's orbit. That curve traced through the same heliographic longitudes as the comet's intercept point. For the few scientists willing to entertain the thought, the implication was staggering. Earth had felt the impact through magnetic resonance, as if connected to the interstellar collision by invisible filaments of energy. Mainstream agencies refused to acknowledge any link. NASA's official space weather summary for the period made no mention of magnetospheric anomalies, and the USGS attributed the quake cluster to statistical coincidence. Yet independent researchers noticed something strange. Even the planet's atmosphere seemed to react. Barometric pressure sensors across multiple continents recorded transient spikes, tiny, simultaneous jumps in air pressure lasting less than a second. Infrasound detectors, usually used to track volcanic eruptions and nuclear tests, logged short, inaudible booms in the upper atmosphere. None had a local source. The signal appeared to come from above, propagating downward. For those studying resonance physics, it began to look like a global standing wave, a planetary-scale echo of the CME event transmitted through magnetic and atmospheric layers. The Earth, it seemed, was ringing. To understand how, one must remember that our planet exists inside a giant electromagnetic bubble, the magnetosphere, connected to the Sun through long, twisting magnetic field lines called Birkeland currents. Under normal conditions, these lines carry charged particles that produce auroras and regulate space weather. But if a foreign body like 3I Atlas temporarily entered that network and interacted with it, it could alter the entire system's frequency. Essentially, it could retune the solar system's magnetic harmony. That hypothesis gained traction when ESA's Swarm satellite constellation, which measures Earth's magnetic field in fine detail, recorded unusual vortices during the event window. The data showed spiraling patterns, double helices of magnetism, forming and dissolving along the dayside magnetopores. They resembled interference patterns, as if two overlapping frequencies were colliding. The frequencies matched, once again, the 11.7-second modulation from the comet. It was as though 3I Atlas had become a temporary tuning fork for the Sun, vibrating through the solar wind and sending ripples across interplanetary space until they reached Earth. But there was more. In the days that followed, atmospheric scientists began reporting faint auroral phenomena visible at latitudes far too low for normal solar activity. Over Texas, Morocco, and southern China, cameras captured fleeting green arcs, faint, pale, almost ghostly. They lasted only seconds before fading. No solar storm alerts were active. Space weather monitors recorded no Earth-directed plasma, so what were people seeing? The simplest answer would be subvisual airglow intensified by magnetospheric waves, but a handful of researchers suggested a bolder, Explanation: these were the visible footprints of the same
resonance pattern that had pulsed
through Earth's magnetic field, a literal visualization
of invisible energy waves. If that were true,
it meant the CME-3I Atlas event didn't just produce electromagnetic disturbances.
it generated a standing wave that briefly
Synchronized the magnetic fields of the Sun and Earth, a global resonance pattern, and that synchronization might explain an even more bizarre coincidence. On September 28th, 3 space-based instruments, Parker Solar Probe, Stereo A, and ACE, each recorded subtle fluctuations in the background solar wind plasma frequency. The oscillations were weak, but identical across platforms. At the exact same moment, Earth's magnetic field exhibited matching periodic variations. It was as though both systems, the heliospheric plasma and our planet's magnetosphere, were vibrating in unison. One physicist described it as a transient coupling event, but privately admitted it looked more like harmonic resonance. Imagine
striking a bell in space, he said.
the sound doesn't travel through air, it travels through magnetism. The Sun rang the bell, and Earth heard the tone. That tone, according to archived measurements, corresponded roughly to 0.085 Hz, a frequency near the first mode of Earth's natural Schumann resonance. In other words, the planet's fundamental electromagnetic heartbeat had briefly synchronized with the Sun. The implications unsettled even the skeptics. Could a solar event, indirect and distant, actually influence seismic, atmospheric, and geomagnetic systems simultaneously? Or was it all coincidence, a statistical mirage born of over-analysis? If coincidence, it was an elegant one, the same pattern repeating across disciplines, instruments, and continents. But those who followed the data deeper noticed that this wasn't the first time such synchrony had been recorded. Historical archives from 2017, the year of Oumuamua's flyby, revealed a faint but similar pattern of magnetospheric irregularities, auroral spikes and low-level seismic clustering, all within 48 hours of that interstellar visitor's closest approach to the Sun. Back then, it was dismissed as noise. Now it looked like precedent. Could it be that every interstellar object passing through the heliosphere triggers these hidden harmonics, small, temporary alignments between cosmic bodies? If so, what we call space weather might be only one facet of a deeper system of resonance, a cosmic rhythm linking stars, planets, and the travelers that drift between them. In that framework, 3I Atlas wasn't just a comet, it was a tuning key. The CME striking it wasn't an accident, it was a chord being played, and Earth, sitting on the edge of the same magnetic scale, couldn't help but vibrate in sympathy. It's easy to dismiss such language as poetic, but resonance physics is unforgivingly literal. When frequencies align, energy transfers effortlessly, often invisibly. The phenomenon underpins everything from quantum transitions to ocean tides. Why not planetary magnetism? Still, official agencies avoided comment. The pattern of global resonance, as it came to be known in underground research circles, never appeared in peer-reviewed literature. Yet leaked data from NASA's Themis mission confirmed what many already suspected. The magnetosphere's electron density fluctuated periodically for days after the CME-3I Atlas event, as if recovering from a sustained oscillation. The resonance slowly faded, but not before leaving traces everywhere. Slight variations in atmospheric electricity,
Unexplained radio noise in deep space antennas.
even minor synchronization errors in GPS satellites. The world had, in effect, experienced a microscopic magnetic earthquake. And then, almost as abruptly as it began, it was over. By early October, readings normalized. The skies quieted. Earth's field steadied into its usual rhythms. The scientific community moved on, but the few who'd watched it unfold couldn't unsee the symmetry. The data arcs, the temporal overlaps, the pulse that tied space and ground together like a single instrument string. It wasn't proof of communication, but it was proof of connection. Somewhere in the silence between the CME's birth and its impact on 3I Atlas, a wave had traveled outward, through plasma, through magnetic fields, through the invisible medium that binds the solar system together. And Earth had answered, however faintly, a pulse from the sun, an echo from an interstellar visitor, a resonance that rippled through the bones of our world. Coincidence or pattern? Science says the former. But the universe has a history of turning coincidences into clues. The silence from deep space monitors, it started as a flicker, then a void. Between 0313 and 0320 UTC, the same narrow window when 3I Atlas vanished from telescopic view and Earth's magnetometers spiked. The vast listening posts of humanity fell quiet. NASA's Parker solar probe, ESA's solar orbiter, and Japan's Hinode all experienced simultaneous data interruptions. But beyond them, further out, something stranger unfolded. Deep space monitors, Voyagers, outposts, and probes that never sleep stopped transmitting. For 7 minutes, the solar system itself seemed to hold its breath. Voyager 2, over 20 billion kilometers away, registered a faint voltage surge across its cosmic ray detector before dipping into silence. The Deep Space Network lost its lock, receiving only static, laced with a rhythmic hum that technicians described as structured noise. Pioneer 10, whose faint signal had been nearly lost for years, emitted a single anomalous ping, a narrow-band pulse at 2.29 GHz, before falling dark again. To the public, nothing was reported. To the agencies, the logs were quietly marked as telemetry dropout due to solar interference. Yet the solar event in question hadn't been directed at Earth, nor at the spacecraft. Every probe was positioned outside the CME's direct path. There should have been no interference, and yet they all went silent together. Inside the Jet Propulsion Laboratory, engineers noticed another anomaly. The timing offset between ground transmitters and deep space receivers had drifted by exactly 11.7 seconds, the same periodic modulation first detected in 3I Atlas's altered spectrum. It was as if a signal, invisible yet omnipresent, had pulsed through the heliosphere, resetting the clocks of machines scattered across billions of kilometers. When the probes reawakened minutes later, most resumed normal transmission, except for Parker's solar probe. Its onboard instruments rebooted automatically. But one subsystem, the Fields experiment, responsible for measuring electric and magnetic variations, returned corrupted data. The logs were filled with repeating hexadecimal patterns: 4F, 55, 54, 2D, 53, 59, 4E, 43. A harmless glitch, perhaps, until one engineer translated it into ASCII. It spelled 2 words, out, sync. That coincidence alone might have been dismissed, if not for what came next. A day after communications normalized, analysts at ESA's Operations Center in Darmstadt discovered that solar orbiter's magnetometer data contained a gap, not of missing time, but of flattened amplitude. The sun's magnetic signature, normally chaotic and shifting, had been compressed into near silence. The field had not vanished. It had cancelled itself, reduced to 0 within the instrument's sensitivity threshold. For 3 full minutes, the sun's magnetic heartbeat had flatlined. It wasn't an absence of power. It was perfect interference, like 2 identical waves meeting in opposition. When plotted, the data formed an eerie symmetry, a cancellation curve centered precisely on the moment of the CME 3I Atlas impact. Physicists proposed explanations: instrument recalibration, data compression error. But the deeper they looked, the less the data behaved like a glitch. It was too smooth, too mathematically precise. It was as if the sun had been momentarily silenced. Across the solar system, the pattern repeated. Cassini's archived telemetry, still trickling back years after the mission's end, showed a microburst in Saturn's magnetosphere during that same window, a compression wave that appeared to come from nowhere. Juno, orbiting Jupiter, registered a brief radio frequency spike in the 1 MHz band, far outside normal Jovian emissions. Even New Horizons, coasting beyond Pluto, recorded a faint shift in background plasma density. Every instrument that could sense the universe's electromagnetic heartbeat heard it skip. And then, once again, that pulse, 11.7 seconds. The rhythmic hum embedded in the static of the deep space network wasn't random. When engineers ran it through fast Fourier transform analysis, the frequency domain revealed harmonic spacing, exact integer multiples of the same base interval. It wasn't noise. It was structured, but no one could find the source. If the signal had come from the sun, its intensity should have followed an inverse square decay, weakening predictably with distance. Instead, its amplitude was nearly identical across probes separated by billions of kilometers. That meant the signal wasn't radiating from a point. It was resonating throughout space itself. It behaved like a standing wave, an electromagnetic vibration within the heliosphere, bound between the sun and something else. What was that something else? The data pointed back toward the location of 3I Atlas. When triangulated, the timing of the silence formed a straight geometric line from the comet's position through the sun's axis and outward toward the direction of Voyager 2. It was a direct alignment, sustained for minutes, as if an invisible filament had connected every listening device in the solar system through a single
resonant path. The pattern was too clean, too synchronous
to be random, and then the human systems began to respond. At the Deep Space Network's Canberra complex, technicians monitoring the anomaly reported hearing a faint clicking through their headsets, not through radio signal, but through the building's electrical grounding itself. The clicks followed the same 11.7-second interval. "It's like the whole room's breathing," one wrote in a log. Elsewhere, unrelated equipment began to behave oddly. A weather station in Norway recorded microvolt oscillations in its lightning detectors that mirrored the solar data. Power grids in Finland and Canada reported transient surges lasting milliseconds, too brief to trip systems but strong enough to register. Even civilian shortwave radio operators claimed to hear a deep, thrumming tone that faded in and out of background static. In each case, the timing lined up exactly. The silence from the deep space monitors had not been silence at all. It was absorption, a phase of coherence so intense that opposing magnetic fields cancelled out, creating apparent stillness while embedding rhythm. The universe wasn't quiet. It was singing in a key too low for human senses. When Parker Solar Probe's corrupted logs were finally decrypted weeks later, analysts found one final anomaly. Buried within the binary data of the Fields instrument were 6 consecutive data packets containing impossible readings, negative magnetic flux values. Magnetic flux can't be negative in physical reality. The polarity can reverse, but magnitude cannot dip below 0. Yet the probe recorded 6 perfect inversions, spaced 11.7 seconds apart. Each one was followed by a blank gap, like a skipped heartbeat. NASA's report labeled them instrument reflection artifacts, and that was the end of it publicly. But internally, one of the engineers made a note in the file's metadata. Phase lock to unknown external source. Possible coherent interference between solar field and interstellar EM event. That note was deleted from the public release version. When the data leaks reached the independent research community, the implications sent ripples through fringe physics forums and even a few legitimate conferences. If coherence could reach that scale, synchronizing magnetic systems across millions of kilometers, It suggested the heliosphere might occasionally behave as a single organism, capable of phase resonance between distant points, and in that organism, 3I Atlas had become a temporary neuron to those who believed the silence wasn't empty. It was communication, the moment when the sun's electric circuits briefly aligned with an interstellar frequency and, for a breath, synchronized. But communication implies consciousness, or at least intention, something mainstream science refuses to entertain. Still, a handful of senior scientists couldn't shake the unease. Among them was Dr. Isabelle Fournier, a plasma physicist with the European Space Agency. Reviewing the overlapping telemetry gaps, she noticed something uncanny. When plotted against solar rotational coordinates, the points of data loss across different satellites formed a logarithmic spiral, the same mathematical pattern that defines coronal loops and even galactic arms. Either it's coincidence, she told a colleague, or the universe keeps speaking the same language. What troubled her most was the aftermath. In the hours following the silence, the sun's outer corona dimmed slightly in ultraviolet light, as if something had drawn energy away. Instruments recovered, but the corona's baseline brightness remained subtly reduced for days. Energy conservation demanded an explanation. If that energy wasn't radiated outward, where did it go? One speculative answer: it traveled along the same resonant field that had silenced the monitors. Absorbed, transmitted or mirrored through 3I Atlas itself. If true, it would mean that for a fleeting moment, the interstellar object didn't just interact with solar plasma, it conducted it. Like a tuning fork struck by a cosmic hammer, it vibrated, sending a silent chord through space. That chord shut down our machines. It crossed magnetic boundaries. It echoed inside the architecture of the solar system, and when it faded, the universe exhaled, leaving behind a strange, rhythmic residue in our instruments and a handful of scientists staring at symmetrical gaps in the data, knowing full well that nature rarely erases itself so cleanly. Some call it a system glitch, others a coincidence. But among those who've seen the raw telemetry, there's another name whispered quietly, never in official papers, only in passing conversation: the 7 minutes of resonance, because for 7 minutes, every deep space monitor fell silent, not because they failed, but because something else spoke louder. The hidden geometry. For months after the silence, researchers tried to move on, cataloging data, filing summaries, reasserting normalcy. Yet something in the numbers refused to stay still. When heliophysicist Dr. Isabelle Fournier began plotting the trajectories of the CME, the path of 3I Atlas and Earth's magnetic orientation during the event, a strange symmetry began to emerge. At first, it was nothing more than a curiosity, a geometric coincidence buried in orbital mechanics. But as she layered datasets from different observatories, a startling image took shape. The Sun, Earth, and 3I Atlas had formed an almost perfect right angle at the precise moment of the CME impact. The Sun at the vertex, one line extending toward the interstellar object, the other toward Earth. It wasn't a rough alignment. The deviation was less than 1/10 of a degree. To any astronomer, that was statistically impossible, cosmic. Alignments happen, yes, but rarely with such precision during a transient event. The heliosphere is chaos. Magnetic storms, charged dust, moving targets. For a coronal mass ejection to curve perfectly along one leg of that triangle and strike the comet exactly as Earth sat on the perpendicular line was beyond random chance. The odds were calculated at roughly 1 in 1,000 billion. But there it was. As Fournier dug deeper, the geometry deepened. The CME's propagation plane, when viewed from the Sun's north pole, showed curvature resembling a logarithmic spiral, the same mathematical ratio that defines solar coronal loops, hurricanes, seashells, and even galactic arms. That spiral passed directly through the coordinates of 3I Atlas's position at the time of impact. In other words, the CME followed the Sun's own internal pattern, a self-similar geometry replicated at vastly different scales, and the comet had entered that spiral at exactly the right phase angle to trigger resonance. When she presented the findings to her department, colleagues dismissed it as numerology. "The Sun produces thousands of CMEs a year," one said. "Overlay enough data and you'll find whatever pattern you want." But Fournier had accounted for that. She ran the same geometric tests against every CME from the past decade. Not once did another event produce a comparable angular alignment with both an interstellar object and Earth simultaneously. Something about this one was special, as more. Independent analysts replicated her results. Whispers of a solar geometry anomaly spread through underground scientific circles. Amateur astronomers began mapping their own orbital reconstructions and found even stranger details. When all vectors were plotted in three-dimensional space, the angle formed by the Sun, Earth, and 3I Atlas wasn't just a right angle. It was phi-based, fitting almost exactly within the golden ratio 1:1, 618 between the CME's velocity vector and Earth's orbital tangent. That ratio, the same that appears in natural systems from DNA helices to galaxy spirals, wasn't supposed to mean anything in this context. Yet it appeared again and again, embedded in the event's timing, its curvature, and even the spacing of the 11, 7-second resonance pulses recorded across the solar system. Coincidence or code? For many, it was an uncomfortable question. Geometry, after all, had been the earliest language of astronomy, the way humanity first read patterns in the heavens. The Babylonians saw divine structure in planetary alignments. Kepler described orbits as the music of the spheres. Modern science had stripped that poetry away. Yet here was a moment when the universe seemed to hum in perfect harmonic proportion, and geometry, as always, was the key. In an unpublicized internal report, ESA's Solar Dynamics division modeled the CME trajectory as a set of magnetic field lines instead of a simple plasma mass. When they traced those lines backward in time, before the eruption, they discovered something extraordinary. The flux rope that birthed the CME had formed along an arctangent to the Sun's equatorial magnetic neutral line, intersecting the same heliographic longitude as 3I Atlas's inbound trajectory. Translated from technical jargon, the Sun's magnetic field had already been aimed at the comet before the eruption occurred, which raised the impossible question, was the CME's direction predetermined? To most physicists, that bordered on heresy. Solar eruptions are chaotic, shaped by random instabilities in the magnetic corona. They do not aim. But the alignment, the timing, and the geometry all implied some hidden order behind the chaos, as though the Sun and 3I Atlas were part of a larger, synchronized mechanism. As more data poured in, the coincidences multiplied. When plotted on a logarithmic polar grid, the coordinates of the CME, the comet, and Earth formed a shape that repeated every 360-degree rotation of the Sun, a tri-spiral lattice identical to the geometric structure of standing magnetic waves observed in plasma confinement experiments. In those experiments, the pattern signifies stability, a resonance point where energy transfer is maximized and loss minimized. In simpler terms, the Sun, 3I Atlas, and Earth had briefly formed an energy circuit. During that short alignment, magnetometers on Earth detected harmonic oscillations not just at 11, 7 seconds, but at exact multiples of the golden ratio, one frequency at 0.085 Hz, Earth's Schumann resonance, another at 0.137 Hz, and a third at 0.222 Hz, each separated by F proportional intervals. These weren't random blips, they formed A harmonic ladder, a resonance structure that could only exist if the system were temporarily phase-locked. Phase-locked between what exactly? No one could say for sure. A few plasma physicists proposed an elegant but disturbing model. If the sun's magnetic field behaved as a self-organizing dynamical system, it might spontaneously form geometric resonances with conductive bodies within its influence. When 3I Atlas, an electrically charged metallic-rich interstellar body, entered one of those harmonic nodes, it could complete the circuit, channeling solar energy along a defined geometric path. The result would look exactly like what had happened: a CME bending off course, striking the object precisely at right angles to Earth, and setting off a wave of resonance through the heliosphere. But even that model couldn't explain the fine details. When Fourier analysis was performed on the 11.7-second modulation, faint subharmonics appeared, forming a sequence of ratios that, when converted into spatial geometry, matched a tetrahedral grid, the same geometry that underlies stable plasma vortices in magnetic confinement systems. The same geometry found, curiously, in patterns of planetary spacing across the solar system. The same geometry ancient civilizations once built monuments to mirror. Coincidence, the skeptics said. Pattern-seeking minds imposing symmetry on chaos. But geometry doesn't lie. It either fits or it doesn't. And in this case, it fit too perfectly. Then came the final revelation, uncovered by a team of data engineers reprocessing the SOHO coronagraph footage. They discovered faint, concentric ripples expanding outward from the CME Comet intersection point. These ripples weren't optical artifacts. They appeared in both visible and ultraviolet channels. The spacing between each ripple decreased logarithmically, converging toward the same phi-based ratio found in the other data. The sun had released not just plasma but a pattern, a wave structured by mathematics. And as those waves expanded outward, Earth's instruments, magnetosphere and atmosphere, had responded in kind. To those who believed in coincidence, it was an elegant curiosity. To those who believed in structure, it was something else entirely, evidence that the universe itself might be wired with geometry, not just in form, but in function. When asked about the findings during a rare interview, Dr. Fournier simply said, "It's as if the sun was following an invisible template." The interviewer laughed, asking whether she meant divine design. She smiled faintly and replied, "Not divine, just coherent." Coherence, the organizing principle that bridges chaos and symmetry, randomness and rhythm. In plasma physics, coherence gives rise to stability. In consciousness, it gives rise to awareness, and that perhaps was the most unsettling question of all. Because if the sun's eruptions can obey geometric laws so intricate they mimic design, then maybe stellar systems aren't accidents of thermodynamics. Maybe they are participants in something larger, a cosmic architecture we're only beginning to glimpse. In the months following the event, geometric alignments between planetary magnetospheres and solar flares were re-examined. Some patterns reappeared. Faint phi ratios in CME propagation paths, angular coincidences between solar storms and seismic activity. None as precise as the 3I Atlas event, but enough to suggest it wasn't unique. In every case, the same ratio whispered through the numbers. 1.618, the same constant carved into the structure of galaxies, the shells of Nautilus, and now, it seemed, into the fire of the sun. A universal signature, a hidden geometry. And as the data analysts pored over those harmonics, the question grew heavier. Was the alignment that guided the CME an accident, or part of a repeating pattern, a rhythm written into the code of creation itself? The event left no debris, no scars, only numbers, ratios, perfect symmetries.
In the silence of space, those numbers echo still. The faint outline of a shape too vast for eyes, too precise for coincidence, too ancient to name. Geometry is truth, the ancients said. Maybe they were right.
Maybe, for one brief moment, truth revealed itself. In the path of a storm, the fall of a comet, and the perfect angle that bound them both to the world that watched in awe.